Okay, for Thursday, let's go ahead with some of the chapter 10 review. And they're listed in here. And so 74 to 82 was the last video, which was a section review. We're going to go from 96 up to somewhere in here if we can get as far as 130. That's what I've got looked at. So let's go ahead and get about 10 minutes of this knocked out of the way. All right, so from page 358, number 96, the recommended daily allowance of selenium in your diet is 6.97 times 10 to the minus 7th mole. How many atoms of selenium is this? Well, there's 6.022 times 10 to the 23rd atoms in a mole, or molecules, or ions. So 23 minus 7, I don't know, 16-ish? 15, 16 or so orders of magnitude is still a huge number of atoms. So you would take 6.97 times 10 to the minus moles of selenium atoms, convert moles to atoms by 6.022 times 10 to the 23rd. Remember, a mole is this many atoms is a mole. And it's still going to come out to be 4.2 times 10 to the 17 atoms. If this number would have been smaller than that one, this would have come out to 16. But this number is smaller than that one. Punch it in on your calculator, make sure you're getting this. Punch it in the way I showed you. If you have trouble with that, ask. 100. If you could count 2 atoms a second, how long would it take you to count a mole? Well, since a mole is enormous, a long time. A long time. Like history of the earth, long time. Assume that you counted 24 hours every day, and how does the time compare? Calculate with the age of the earth, estimated to be 4.9 times 10 to the 9th years old. That's 4.5 billion years old. So it's a long conversion analysis. And so the way you would do that is you are looking for, I don't know what, seconds? Years. We're going to do years, okay? So there's 6.022 times 10 to the 23rd atoms. At 2 atoms a second, we just cut that number in half, but it's still enormous. And there's 3,600 seconds in an hour. And there's 24 hours in a day. So that cancels. And there's 365 and a quarter days in a year, call it 365. So it would take 9.54 times 10 to the 15 years. And if we take 9.5 times 10 to the 15 years and divide it by 4.5 times 10 to the 9th years, that's 2 million times greater than the estimated age of the earth. Older than the universe by, I don't know, about 0.7 million times, roughly. So, something like that. Impossible, obviously. Number 102. Explain the difference between atomic mass in AMUs and molar mass in grams. You get the same number. Atomic mass is for one element, or one atom, or one molecule, or one ion, or one electron. The molar mass is the same number, but it's for the grams for that number, for a mole. And that's the one we're going to use. Atomic number, I'm not very concerned about. It's not useful to us. In chemistry, it might be useful in, push the wrong button here. In physics, it may be useful, but in chemistry, it's not particularly useful. So atomic mass in AMUs measures one formula unit, or one atom, or one ion, or one molecule. Molar mass in grams per mole measures a mole of an element, or a mole of a compound, or a mole of an ion, or a mole of a molecule, or something like that. Of a compound, I guess I should say. And this one is the one that we will use. We aren't really going to use that one. 108. Calculate the mass of each element. Okay, I'm going to expect you to do all of them in 108. So you have to pause the video if you haven't already worked ahead and do all of them. I'm going to show you one, so I'll know who did all of them and I'll know who just got the things down, whether or not you did all of them. And I think I have, well, I'll just check here. I have B. So A and C and D you should also be able to do, and I can real quick check, see if you have right answers on, if you did them right. But on B, you have 0.0455 moles of nickel. So if you are looking for grams of nickel, and you know you're starting with 0.0455 moles of nickel, and you put that over 1, and then you convert moles nickel on the bottom, grams nickel on the top, and you get the number from the periodic table, which is 58.79, and you multiply those two, you will get 2.67 grams of nickel. And there's 3 digits here, you got 4 there. No, the 3 there, I guess. You're gonna have to go with 3 because it's your worst, so 2.67. Don't worry about significant figures though. Okay, next one was 111. From your list, 111. Complete table 3. You got mass, moles, and particles. You should crunch the numbers on that. Let me do chromium, for example. Okay. And they tell you you have 29.54 grams of chromium. You convert grams of chromium to moles, and you'll get about a half-ish, 0.568 moles chromium. That'll go in your middle blank. And your particles, you take the moles and turn it into particles. So you're going to multiply it by Avogadro's number. Moles chromium goes down here, atoms chromium goes up here. It's this number of atoms regardless of which element it is. And it comes out to about 3 and change times 10 to the 23rd. 3.42 times 10 to the 23rd. So you have all the blanks there. Now, I need you to do the calculations for all of these, which I can see whether or not you have done. And you turn this in. And when your results, just so that you can check them, should come out like that. So you may want to pause this and look and see what you got. So we just did chromium here. But like on this one, you're going to take magnesium and you're going to convert it this way and that way. And you should get those. So check that you're getting them and that you know how and why you're getting them. Okay. And we'll do one more. I'm going to stop. And that's 117. Because I want to quit. Which has more atoms, 10 grams of carbon or 10 grams of calcium? And how many atoms does each have? Okay, the one with least molar mass, carbon is 12, is going to have more atoms if the masses are equal. And calcium is 40. In fact, they're about, I don't know, they're not a 4-to-1 ratio. They're like 3.6 or so to 1 ratio. And they want you to go ahead and count up the atoms. So if you do it that way, and you say on the first one, oh, I want atoms of carbon, and I'm given grams, I have to go from grams has to be here, moles has to go up here, and 1 mole of carbon is 12 grams, and moles has to go here, and atoms has to go there. Multiply the tops, multiply the bottoms, then divide. This is what you come up with. If you're not coming up with this, make sure you know how and why. What was I going to say about this? Can't remember. Okay, this is number of atoms per 1 mole. This is the molar mass per 1 mole. If you do the same thing for calcium, we had 10 grams of calcium. but it's 40 grams of calcium per mole, grams cancels. A mole is this many atoms regardless of what element it is. So here I cancel calcium, but I got one left over. Here I cancel carbon twice, and I still have one left over. Multiply the tops, multiply the bottoms, then divide. You can do this with your head though, because you have 10 over 40 is a quarter, and a quarter of 6 is 1.5. So it's going to be 1.5055, I think, because it's a quarter of that. And those digits don't count because these are 2, these are 2. Actually, those are 1. 1.5 times 10 to 23 atoms of carbon, or calcium, and we'll pick up from there.